a voyage through time from fiction to fact. The concept of time travel has captivated humanity for centuries. It has fueled our imaginations and sparked countless stories. From H.G. Wells' groundbreaking novel to blockbuster films like, we have always been fascinated by the possibility of venturing through time. Imagine witnessing historical events firsthand or catching a glimpse of the distant future. The allure of time travel lies in its power to transcend the limitations of our present reality. While time travel has long been relegated to the realm of science fiction, recent scientific advancements have brought us closer to understanding its potential. Einstein's groundbreaking theories of relativity laid the foundation for our current understanding of time as a flexible entity, capable of being warped and distorted. Could this understanding one day unlock the secrets of time travel? Bridging the gap between imagination and reality. Before we delve into the complexities of time travel, it's crucial to distinguish between the fantastical portrayals often depicted in science fiction and the scientific realities we currently understand. Science fiction has long been a playground for our wildest dreams, where the impossible becomes possible, and the boundaries of reality are stretched to their limits. Science fiction often takes creative liberties with the concept of time travel, presenting it as a seamless and easily achievable feat. Iconic movies and books have shown us worlds where characters hop through time with the push of a button, creating a sense of wonder and excitement. However, the scientific understanding of time travel is far more nuanced and complex. The theories and equations that underpin our current knowledge are intricate and often counterintuitive, requiring a deep understanding of physics. While we haven't quite cracked the code to building a working time machine, the laws of physics, as we understand them, do not explicitly prohibit time travel. This tantalizing possibility keeps scientists and enthusiasts alike intrigued and hopeful. This intriguing possibility arises from the nature of time itself, which, according to Einstein's theories, is not a constant but rather a relative entity that can be influenced by factors such as speed and gravity. These factors can warp time, making it move faster or slower depending on the conditions. This understanding forms the crux of our current exploration into the potential for time travel. As we continue to study and experiment, we inch closer to unraveling the mysteries of time and perhaps one day making the leap from imagination to reality. Einstein's universe. Time is not absolute. Albert Einstein's theory of relativity revolutionized our understanding of space and time. Prior to Einstein, time was considered absolute and unchanging. However, Einstein proposed that time is relative, meaning that it can be experienced differently depending on an observer's relative motion and the gravitational field they are in. This revolutionary concept, known as time dilation, is key to understanding the possibility of time travel. Imagine a giant clock on Earth and another identical clock aboard a spaceship traveling at incredibly high speeds. According to Einstein's theory, time would pass slightly slower for the clock on the spaceship due to its high speed. This phenomenon, known as time dilation, suggests that time is not a rigid, unchanging entity, but rather a fluid dimension that can be stretched and compressed. The spaceship of tomorrow, a journey to the future. Imagine a vessel that can traverse the cosmos at unimaginable speeds, taking us to the farthest reaches of the universe. Time dilation, while a mind-boggling concept, is not merely a theoretical notion. It is a phenomenon that has been observed and measured in scientific experiments. It has been experimentally verified using atomic clocks, demonstrating that time does indeed pass slower at higher speeds, albeit the difference is minuscule at everyday speeds. These experiments have provided concrete evidence supporting the theory of relativity. However, as we approach the speed of light, the effects of time dilation become increasingly pronounced. The faster we travel, the more significant the time difference becomes. Let's imagine a spaceship capable of traveling at a significant fraction of the speed of light. Such a journey would not only be a marvel of engineering, but also a profound leap in our understanding of time and space. If this spaceship were to embark on a journey into space for a few years, as measured by the onboard clock, decades could pass on Earth in that same time frame. This means that while the astronauts experience only a few years, the world they return to would have aged significantly. Upon their return, the astronauts would have effectively traveled into the future. They would witness the changes and advancements that occurred during their absence. This concept, while technologically challenging, is rooted in the principles of physics and demonstrates the potential for time travel to the future. It opens up a realm of possibilities for humanity's exploration and understanding of the universe. Wormholes shortcuts through space and time. While traveling to the future using time dilation is theoretically possible, journeying to the past presents a far greater challenge. One intriguing concept that captures the imagination is the idea of wormholes. Imagine space-time as a fabric that can be folded. A wormhole, theoretically, would be a tunnel connecting two distant points in this fabric, essentially a shortcut through space and time. While wormholes remain highly speculative, their existence is consistent with Einstein's equations of general relativity. These theoretical tunnels could potentially allow for travel between different points in time. However, the challenges associated with creating and stabilizing a wormhole are immense, requiring exotic matter with negative mass energy density, a concept yet to be observed or created in any laboratory. Black holes, gateways to the past. Black holes, those enigmatic cosmic entities, also hold potential clues to the mysteries of time travel. These gravitational behemoths warp space-time to an extreme degree, creating a region where gravity is so intense that nothing, not even light, can escape. This extreme warping of space-time around a black hole has led some physicists to theorize about the possibility of time loops. Imagine approaching a rotating black hole. The immense gravity would not only distort space, but also time. Some theories suggest that this distortion could create closed, time-like curves, essentially loops in time. If a spaceship were to navigate these loops successfully, it could potentially emerge in the past. However, the conditions near a black hole are incredibly hostile, and the journey itself would be fraught with danger. Paradoxes of time untangling the threads of causality. The prospect of time travel, while exhilarating, also raises perplexing paradoxes that challenge our understanding of cause and effect. One of the most famous is the grandfather paradox. Imagine traveling back in time and accidentally causing the death of your grandfather before your parent was even born. This action would seemingly prevent your own existence, creating a logical inconsistency. While these paradoxes present intriguing philosophical dilemmas, they also highlight the potential limitations of time travel. Some physicists believe that such paradoxes might be avoided through self-consistent principles where the timeline self-corrects to prevent contradictions. Others propose that time travel might not allow for alterations to the past, suggesting that any interaction with the past would simply unfold as it always has. Time travel and the multiverse, a tapestry of possibilities. One intriguing concept that offers a potential solution to the paradoxes of time travel is the multiverse theory. This theory has fascinated scientists and philosophers alike as it opens up a realm of endless possibilities and scenarios. This theory proposes the existence of multiple parallel universes, each representing a different timeline or a different outcome of events. Imagine a universe where every decision you make spawns a new reality, each with its own unique path. In this context, time travel might not be about altering the past of our own universe, but rather about accessing different branches of the multiverse. This means that every journey through time could lead to a new and unexplored dimension. Imagine traveling back in time and altering an event. Instead of merely changing a single moment, you could be creating an entirely new timeline, a fresh branch in the vast multiverse. Instead of changing your own past, you might be creating a new branch in the multiverse, a timeline where that event unfolded differently. This new branch would coexist with the original, each with its own distinct history and future. This interpretation offers a way to reconcile the possibilities of time travel with the preservation of causality, suggesting that our actions might not rewrite our past, but rather contribute to the ever-expanding tapestry of the multiverse. Each thread in this cosmic tapestry represents a unique timeline, weaving together to form a complex and beautiful pattern of existence. The future of time travel, a journey just beginning. While time travel remains a topic of intense scientific inquiry and speculation, the journey towards unraveling its secrets has just begun. The laws of physics, as we currently understand them, do not entirely rule out the possibility of time travel. Technological advancements continue to push the boundaries of what's possible, and our understanding of the universe continues to evolve. The human spirit, driven by insatiable curiosity and boundless imagination, will undoubtedly continue to explore the mysteries of time travel. Perhaps one day, what we now consider science fiction will become scientific reality, opening up new frontiers of exploration and understanding. Until then, the dream of venturing through time will continue to captivate our collective imagination. What wonders await us in the vast expanse of time?